Last time we completed the discussion of feasibility analysis. This lecture is going to be on data flow diagrams. In fact, we had earlier did mention this data flow diagrams, and we did use them in some situations, but we did not go into the great details of how to deal with the data flow diagrams in detail. Data flow diagrams are an important tool for a systems analyst and designer. It is something like a drawing which an architect uses. The advantage of a drawing is, on the one hand, it should be understood by the person who is going to implement it, namely the engineers and so on, and also by the user who is going to ultimately live in the building. So, the plan or the drawing of the house is something which is useful for two different classes of people. Similarly, data flow diagrams are something which is going to be of use to the systems analyst, to be given to the system designer on the one hand, and to the user of the ultimate system on the other hand. So, in order to be able to come up with a tool of this type, we need to have some characteristics of this diagram which is easily understood by both parties, and it is a graphical tool, just like a drawing is a graphical tool. And the advantage of graphical tools are that it is more or less self evident what they really imply. So, the various learning units in this particular module are: what are data flow diagrams? Data flow diagrams are abbreviated as DFDs. I mean, just for saving time, I would say. It does turn out that in computer science we seem to use a lot of acronyms, and even though sometimes I do not like some of these acronyms, we do not understand, still it is a convenience. So, in this context, what I mean by DFD is a data flow diagram. So, we have to first define what are data flow diagrams. We have to look at the symbols used for in the data flow diagram, rules which are there to draw these diagrams, and not only are the rules important, but there is also something called a style. Style is something which is subjective, but still style is important, because just like when you write English, the grammar should be correct, but the style is something which really makes a difference between something which you can read easily and something which is not easily read. In other words, easy on the reader, you might say. Okay. Style is extremely important. So, the good style is what we are going to be emphasizing. We will describe how to use DFDs for large systems, and there is something called leveling of DFDs. I will describe leveling in greater detail. The whole idea in leveling is that when you make something very, very complex and very detailed, people find it difficult to absorb what they really imply, whereas if you break it up into smaller parts, then it is easier to understand. So, leveling is nothing but breaking up something which is too complicated into something which is, you might say, hierarchical, starting with something as an overview and then breaking it up into smaller parts. So, each part can be explained in greater detail. And there are two types of data flow diagrams. One is called a logical data flow diagram, which is primarily for the logic of the programs you are going to implement and so on, and physical data flow diagrams, which primarily say what physical documents, what physical goods, items and so on flow in the system. So, there is a lot of difference between physical goods and the equivalent of the physical goods as a document giving a description. So, a data flow diagram, the logical part only deals with the description. So, again to emphasize, the learning units are what are data flow diagrams, why are they useful, how are they developed, how to level DFDs, good style conventions in developing DFDs, difference between logical and physical DFDs, and tools which are available to draw DFDs. I will not go into great details about the tools, because the tools are something which will make it easier to do the drawing of these things. And of course, as you know, today in computers there are many drawing tools available. So, those drawing tools can be used, and it is not a part of this course to talk about how to use paintbrush or draw and things like that in computers, but there are also other tools that are available to check the logical correctness of DFDs, and this is some of the details about this is given in the written notes which accompanies these lectures, particularly the sites which are there, where you can look at these sites and download some of the cheap or no cost tools which a student can use, because there are also tools which are made by professional companies, and they cost a lot of money, and for a student and for colleges to own them is expensive. So, it is always all right to get an idea of what these tools mean, how they are used from the by using the so called open domain tools. And so that will be, the websites will be given in the lecture notes. Apart from the lecture notes and the PPTs which accompany this lecture as the written part of this course, I am also using, as you know, this book Analysis and Design of Information Systems, and I am essentially going to cover chapter 7, which is data flow diagrams, which is what this entire lecture is about. A book has of course lot more detail than what I can really hope to say in 1 or 2 hours. So, one should actually go back and read the book also after listening to the lecture. In fact, it will be better to read before you come to the lecture, but I know that most students do not do that. Even if they read it after the lecture, it is a good student who does it, and many students do not worry about it. In any case, it is important to be able to have a support material. In this, for this course, support material is in terms of the web support material, which is part of this program, and also I have talked about the availability of a textbook which is going to be closely followed by me. The question of why should we use DFD, I already said something about this, and it essentially provides an overview of what data a system processes, and that means what are all the different data elements which are essential to get the reports which are to be generated by the system. The reports, what I mean by reports, are operational reports, reports for tactical management, and reports for strategic management. So, all of this, as we have been always emphasizing, all data processing systems are based on some raw input data being processed by a certain set of processing rules and creating the appropriate operational, tactical and strategic information. So, the processing of data converts the data into information which can be used for taking informed decisions. So, first of all you have to say what are the inputs, that is what are the data which is processed by the system, what transformations are performed, that is transformation is what really leads to your information, and we have to describe these transformations, and what data are stored in any system. In order to transform the data, some will flow inside from outside and some will be stored. For instance, if you are processing student examination results, and you already would have stored all details about the student in terms of roll number, name, maybe college, and all that information will be, all that will be there in some kind of a file, and the results are the ones which are processed. That is, when the marks arrive, you process these marks, add them, find out the class, and then you enter it, and then print out the file. So, in other words, the point is that the file is already ready and kept, then the last minute time taken to process will be much smaller. Otherwise, you start entering everything at the last minute, that will not be very, it will take unnecessarily long time. You already keep a lot of things which are not really going to change and keep it in files. Of course, you read from the file, you process the data from the file based on some inputs, and you write back in the file. So, what data has to be stored? What in other words, stored data is normally called a file or a database. In fact, database is the better word terminology to use, and later on in this course we will look at the databases, now to organize databases. In this particular part, we only assume that there is a store for the data, and what results are produced and where do they flow. Okay. The ultimately there must be a consumer of whatever processed information you have, and so where do they flow. As I said, the DFT is of a graphical nature, and it is because it is of a graphical nature, it is a good communication tool between the user and the analyst and system designer. See, just like an architect deals with two sets of people, one is the user who is the ultimate person who is going to live in that house. So, he has to get the approval of the user about the plan and things like that, and of course, the structural engineer or designer who has to actually construct it. Similarly, system designer, somebody is going to write the programs, create the databases, and all the nitty-gritty details of processing the data to produce results. As far as the user is concerned, the user is only concerned about in this case what data needs to be provided and what kind of process results will he get, and whether the data which has to be provided is something which he can easily provide, or you should not ask for data which cannot be provided. Okay. So, at that stage the user has a role to play, and similarly the information which is created should be of use to the customer. So, in other words, it is all based on the system's requirement specification, which will effectively tell what the results of the system would be, or processed information will be, which will satisfy the requirement of the user. Once this overview is given to the user, then from this overview the designer has to get to, as I said, nitty-gritty details of writing the program, creating the database, and checking out the program, testing it, all that which goes with creating a system. It is a very long process. But the process of creating a systems SRS, that is systems requirement specification, as I said, is very important, because if you start changing it in the middle, then the designer will have a lot of difficulty. Okay. So, that is the in any case the point is that there is two sets of people who have to use it. So, the tool must be such that it should be usable by both. So, the structure of DFD which you are going to design is to start from a very broad overview and expand it into a hierarchy of detailed diagrams. I said that earlier, but effectively it is like if you have a huge building to plan, you will start with an overview of the plan, how it looked like, and you might even give a picture of the house and things like that. But then when you go to each part of the house, you have to do a greater depth of design. Like for a simple house, for instance, a house will consist of many living room, kitchen, bathroom and all that. And so, the overview is just a plan giving the size of various rooms and where they are located and so on. Then the next step is to kind of look at the kitchen, say for instance, and detail out the kitchen, because with all kinds of gadgets which you use in the kitchen, you must provide proper electrical points, you must provide the cupboards, and you must provide a place for your gas stove, and it should be convenient, all those things. In other words, similarly bathrooms, there are hundreds of varieties of bathrooms depending upon the amount of money you are willing to spend and size the bathroom and so on. So, you again detail out the bathroom in great detail. In other words, the overview only gives the structure or the general layout of the building, and then the details give for each room what there will be, and details can go to the extent of telling the electrical points, where had to be put, at what height, and what type of paint to be used, stuff like that. I mean, there is a whole lot of other details which goes into that. Similarly, in a DFD you have an overview structure of what the entire system would look like, and then each step you got to kind of expand it, and I will show it by example. Okay. For house example, it is very kind of obvious because all of you live in houses, whereas in this case you got to learn how to look at an overview and how to divide it up into smaller parts. And DFDs model systems by depicting external entities. There are a number of parts to a data flow diagram. These parts are called external entities and processes. There are files, and there are data flows. Okay. So, there are a number of different what I would say elements. You have to really learn what the elements mean and why the elements are required. So, external entities are the ones from which data flows and in which data terminates. Okay. So, the originator of the data is called an external entity. That is, the reason why it is called an external entity, it is not part of the entire process. Okay. The a person who is going to provide you the input data to process, like a vendor would be an external entity. Okay. A vendor also may be the data can flow from him in terms of the invoice which he sends, and data can also flow to him as a check for payment which is made. So, the same external entity can both send data and receive data. Okay. So, but anyhow they do not generate any data of their own. I mean, what I mean is they do not process any data of their own, they only send data and receive data, and process which transform data flows. Processes are the one which are allowed to actually transform it by, in the case of computers and so on, we know transformations by means of programs. Programs are the ones which take the input data and process them. Okay. There are data stores from which the data is read, into which data is written. As I said, data store, I explained why a data store is required. Okay. Store is something which you will store data, you retrieve data, you process data and write back data, write back process data you might say. And so data stores are the ones where you read data from and write. Now as I said, there are the things I talked about as that the external entities, data flows, processing steps and stores. Okay, these are essentially only 4 items I mentioned. Now each one of them has got a certain symbol in the notation for data flow diagram. The symbol for a process is normally a circle. As you know, these symbols to some extent are standardized in the sense that almost everybody uses, but there are some variations in the symbol. Instead of using a circle, some people use an ellipse, okay. And normally it is circle is easy to draw, as you know, and circle is easy to kind of understand and so on. So by and large, circles is what I am going to be using, okay. And most standards use circles. And data flows are lines with arrows which can be flowing into the process or flowing out of the process, okay. And in this case, the stores, there will be a demand note, and store demand note for the stores to be able to issue the items, and stores also will receive deliveries. So there are 2 data flows I have showed here. One is the demand note of a customer or a user of the store, and a delivery slip, and an issue advice, which is the after it is issued, along with it there is a document which is sent, okay. So these are the input data flows and output data flows. A circle represents the process, straight lines with incoming arrows are input data flows, straight lines with outgoing arrows are output data flows. And as you have seen here, the data flows, there is some kind of a write up above it or below it. This essentially gives a label for the data flow, what the data flow represents, okay. I am not giving a great detail about the label will be detailed later on, but only just says that something called a demand note which is going to go into the stores, okay. Processes are given serial numbers for easy reference. Of course, the number 1 I put there arbitrarily. I mean, serial number is starting with some number, because later on if you want to identify it, serial number is very useful. Labels are assigned to data flow. These aid documentation. Primarily the numbering and the labels are for documentation. External entities are represented by rectangles, okay, and they either supply or receive data, and as I said that they do not process data. So in this case, the vendor, there is an invoice which originates from him maybe, and a customer sends out an order and receives a bill, okay. As I said, same external entity can have arrows pointing inside as well as a arrow pointing outside. Now a data store is represented by 2 parallel lines. In this case, I said inventory, for instance. That data store is a repository of data, it stores data, okay. One can write, as I said, into that repository or read from that repository. So one can very easily say it is a file, I mean, or a database, okay. So data can be written, and this is shown by an arrow. If an arrow points inside, that means you are writing. If your arrow is pointing outside from the store, it means that you are reading, okay. I said this
data can be read from data store is depicted by an outgoing arrow. External entity cannot write or read data into a data store. In other words, the data store is required for the process. Because it is required by the process, if you write directly into the file from outside, that will not be, there is no process of writing which is there in entity. Entity is just you might say dumb animal. So in the sense that the entity is a vendor and so on. Okay. So there is no question of the entity being able to write or read from a file. It has got to be done only by a process. Okay. And two data stores cannot be connected to by data flow. That is also obvious in the sense that in order to read or write into a data flow, into a file, you require some processor in which a process runs, and that processor has the I/O, and so the process gives a request to read or to write, and so reading or writing from a file can be done only by a process or a processor. A processor acting on behalf of a process, because you by now you know the difference between a process and a processor, because in a processor many processes can be running. Okay. One of the processes which runs in a processor is a I/O process. Okay. So the you cannot connect to data stores because both of them are dumb files. There is only two disk drives. It is like saying that how can I write from one disk drive to another disk drive without any intermediate processor being available to take this. So you cannot. I mean, that is, but you have to remember this rule. Data can flow from an external entity to a process to an external entity, process to a store and back, and process to a process. Okay. So in order to check the data flow diagram which you have drawn, these rules are followed. The tools which are there normally will do this somewhat automatically, but then the rules are so simple that it should not be very difficult for you to kind of inspect a diagram and see whether it is you have correctly drawn it. If you have contravened or if you have not followed any of the rules, it means there is a logical error. Logically you have not understood. Writing from file to file obviously is without an intermediate processing is obviously a logical error. Okay. Data flow cannot flow from an external entity to external entity. That is also obvious. When ultimately see the external entity creates data and consumes data, and if you send one from one to the other without any processing step in between, you are just not doing a transformation, just forwarding it. So that is not the purpose of a external entity in a data flow diagram. The external entity data cannot flow from external entity to store. As I said, external entity is a dumb one, and store to external entity. Okay, store has to only talk with the process, and store, which again I am reiterating that. In other words, primarily the intermediary in all file operations is the process, and similarly the intermediary between two external entities is again a process. There is another alternative symbol which is used in some books for the data flow diagram. As I said, some people use ellipsis, and another one is some kind of a rounded rectangle with a label which gives the serial number of that process, and the store issue is the process name, just like we also use the process name like stores processing and so on. So instead of circle they use a rectangle with a rounded edges, and data store is shown as a open rectangle with giving the name of the particular file and also some label for that file. Okay, this is another way of doing it. Again, of course, in this case you could read and write. Either you can show it vertically coming up and or coming down. You see, like you can show it like this, or you can show it like this. Okay, both are all right. I mean, but then the notation would be obvious. A good style in drawing DFDs is to use meaningful names of data flows, process and data stores. The whole idea of using meaningful names is that it is a documentation aid. It is also an aid between the customer and the designer. So something which is descriptive will be immediately understood. If you just use X, Y, Z, it is like in any program when you write, we always tell you that the variable names which you use in a program should not be X, Y, Z and stuff like that. You normally use a meaningful variable name. That is why many of the new programming languages allow you names for the variables which are as long as you wish to have it. Okay. So, but by and large, I mean, you use a reasonable name, so that the semantics or the meaning is obvious for somebody who reads the program, because in program the situation is like you may have written the program and you may have left the company, and somebody else will come later on to maintain your program. So if you write meaningless names, then the other person cannot even understand what you wrote. So meaningful names are essential, and many companies have standards in terms of the importance of meaningful names, and the manager will not accept a program unless you use reasonable meaningful names, and have also dictionary explaining these things. Okay. Similarly, in a data flow diagram, you use meaningful names of data flows, and the data flow itself will consist of a number of individual fields or data items. Okay. And so they have also got to be described, which will come later. Currently we are only talking about the we are not talking about the structure of the data, but we are only talking about the name of the data, what the data is. Use top down development starting from the context diagram and successively leveling DFT. This is what is meant by top down design or hierarchical design. I explain in terms of the house building plan. You have an overall plan, and then you look at each of the separate rooms and detail it. Similarly, you look at an overview and then go downwards. Only previously stored data can be read, obviously. I mean, you can't something can't be read which is not stored. A process can only transfer input to output. It cannot create new data. What is meant by it cannot create new data? I mean, I am saying, of course one might question me, it is creating a new data and says that it is processing. Okay. What I mean is there is some input data, there is some data in the file, and that data which is coming from the input and that in the file together will create the output data. You cannot have something which is coming out in the output which is neither in the input nor in the store. That is what I mean by saying it can not create new data. There is new data element, you might say, okay, but it can create processed data. Okay. Data stores cannot create new data. I mean again for obvious reasons. You can store them, you can read, you can write, but it cannot by itself generate a new data item. In order to kind of generate a DFD, first you have to look at an entire system and represent it by one DFD, which gives a system's overview. It is called the context diagram. The context diagram gives a little detail. It is also known as a top level DFD. Okay. I will explain. I will give an example of what I mean by context diagram, and how it expand it. This is what the whole idea is about, so called leveling. Okay. I will look at the context diagram of a mess management system, which we were talking about the mess management system. We said that this is a running case which I have been using all along. So in the context diagram, you only give an overview of what the mess management system is expected to do and with what external entities it is supposed to be interacting. You do not say anything about the details of the process, and you have to kind of get down to very details by breaking up the mess management system into subparts which do the specific processing. Observe this diagram. It gives very little detail. There are the mess management system has as its users students, mess manager, chief warden, mess secretary, and vendors. See now, you look at what are all the important data elements which each of these entities is going to provide. Now a student, if he is a regular member of the mess, whenever he takes extras and so on or has guests, he has to provide that information. Otherwise it will be assumed there is a member. As a member, having used the facility for a certain number of days, for those number of days he will be charged. Okay. So the student also has to pay payments, and based on the bills which are sent to him, because bills would include both the regular bill plus bills but the additions are extras. So as far as students interaction is concerned, these are the interactions. Vendor gets requisitions for purchase requisition for purchasing items for the mess, and he supplies the items and he gets payments back. So primarily the three most important things as far as the vendor is concerned are requisitions, supplies, and payments. Another way of telling requisitions that you can say an order to the vendor. Okay. And the mess secretary is supposed to be giving a daily menu to the mess management system, and as we have been talking about, the menu should be such that the daily rate should not widely vary, and that the food which you give should be balanced. So these are the requirements of the system. Okay. And so in order to be able to give a reasonable menu, if he has a running daily rate available, then he can adjust so that there is no wide variations in the daily rate. Now the warden, the main warden's major job of course is to make sure is that it is going to be looking at the exception reports primarily, because the day to day running is not of his concern. If there is a overdue payments from students, then in other words we said students are given 5 days or something whatever to clear the bill. If it does not clear the bill, then the information goes to the warden, and so he can call the student and do something about it. And similarly, bills are to be paid in time to vendors and so on, and anything which is overdue, that also has got to be mentioned. These are the things which are required for what I would say not operational. It will not the reports will be smaller number, but they are required to kind of have an overall control of the system. And the other entity we have shown is a mess manager based on the menu, the items needed every day has to be given to the mess manager. Based on that, he will find out what is perishable and things like that. And so, perishable goods processing is somewhat different from the non-perishable goods processing. All those things we discussed, but this gives an overview, okay, of what the entire system is about. Okay, and of course, probably you should have some kind of a write-up to accompany that. If you are going to talk to a manager or a user, this is going to become part of the SRS, Systems Requirement Specification, saying that this is what your system will do. So, this is the kind of entities and process the management system, and give some details of what the management system will do. So, a context diagram gives an overview, should be split into major processes which give greater detail. Each major process is further split to give more and more detail. That is, each one, this becomes a number of processes, and then each process is split further. See, if the DFD is too detailed, it will have too many data flows, it will be large and difficult to understand. This is obvious. In other words, the best thing is something which you can fit into a page. If you can fit in something into a page, at a glance you see what is going on, and you can connect it to other pages, like a flow chart or things like that which you draw. You effectively look at not exceeding a large number. Nobody likes to have a big sheet of paper this big, where all the data flows are given. You will get utterly confused. Okay. So, the point is that each DFD must deal only with one aspect of a big system. That is how we can divide up into not more than one page. Start from a broad overview, expand detail, idea similar to using procedures and linking this with main program. As you know, in programming we have a similar situation. If you have a very complex program, one single monolithic program, it is very difficult to change that program. And so, we always tell students when they learn programming that divide and conquer. That is, divide a large problem to smaller parts, and each smaller part you can write a procedure, and you can link all these procedures or functions, whatever. And of course, now the newer method is again to come up with objects which are reusable objects and so on. So, you create a set of objects and you link all the objects together to make up the big program. Again, it is splitting something into a smaller set of parts which are all can be independently designed. So, it is a similar idea. This idea occurs again and again in computer science, but of course, it is common sense. Nobody would like to look at a big monolithic thing. One would always try to break it up into smaller parts and be able to digest the smaller parts. Okay. And so, the later on in this course we will talk about object orientation also, and that would be also required from the same point of view. That is, in a large system, what are the important objects in that system, and how those objects can be designed and how do you create reusable objects, things of that type. So, similarly, one might even think about reusable parts of a DFD for similar systems. Now, let us look at the expanded DFD for a hostel management system. Now, the overview, the mess management system, we had no great detail. We had number of external entities which we processed. One of the things which is being done in the mess management system is a billing system. The billing system is to produce bills for the students primarily, and so the students can make payments. There is another part of the billing system which also will deal with the vendors, because as I said, the payments are to be made also to vendors. But I am looking at the billing system which is specific to a student. Okay. As you can see here, the itemized bills at the end of the month is what is being generated by this system, and in order to do that, of course, it has got to kind of get inputs from many different entities. Now, the mess manager has to give to the billing system items used each day, and of course, there should be also in some file the cost of the items which are used. Okay. Normally, the cost of the items would normally be stored in some kind of a file. I have not shown that in great detail here, because it will be continued on future figures and so on. The students are going to be sent itemized bills at the end of the month, because that is one of the requirements we set. Previously, they are not getting any itemized bills, and payments come to the billing system, and extras and rebates, the students' extras and rebates in terms of his not being a member of the mess and so on also flows into the system. And the billing system should update daily rates in order for the mess secretary to create a proper menu. Okay. So, that updation is done by billing system, and the billing system also sends the chief warden unpaid bills and also late payments by students. And apart from that, the expenses, number of meals. The interesting thing here is there are two files. One is the student billing information plus bills. What is meant by student billing? You can see the arrow is right both ways. That means it is reading from that file and writing. What is being read from the file is the permanent data about the members of the mess. Okay, roll number and whatever, room number, whatever. Okay, and then as and when they are using guests and so on, bringing guests, or whenever they get going to be absent, all the information is sent to the billing file, so that number of days he has actually used the mess, number of extras he used, all that is immediately updated in that file. That is what it writes in that file, and that is what it is used later on to bill. And the expenses based on the cost of the items used and the menu used and so on is written into that expense file, and also the expense file has been read to be able to generate daily rate update. there is a now apart from the billing system, there is a stores, issue and control system, and also a perishable ordering system. There is vendor orders for both perishable as well as non-perishable items. We will again divide up the ordering system into two parts. One is perishable ordering and non-perishable ordering. But in any case, in this case, as an example, I have shown the stores issue and control system as one DFD which is connected to the previous one. In other words, you can see that I said continued. That means the going to continue to next process, it says. So that line will come as a input to this. Okay. So what should be the label there? The label has been omitted, which is actually an error. Okay. The billing system should generate to the store system the items used and items requested. Okay. So because that is the one which is going to be used by a stores issue. Okay. So the vendor supplies come in and items required is what comes from the previous one, and control system will create an order. Non-perishable order is because probably made once in a fortnight or once in a month, whatever. The period will be determined by the variability of the number of members in the mess. If the number of members in the mess remains reasonably constant month after month, one may decide on a timing of 1 month. Otherwise, if it is variable, then it might be half a month. Depends on the situation. But in any case, it is a bulk order once in a few days, you might say. Whereas a perishable order, something which got done every day, because milk and vegetables and so on, you cannot order a month ahead of time. Because also we have said that the vegetable prices change from day to day, fruit prices change from day to day, and so the billing system also has to have that data. So there is a separate perishable ordering system apart from the in the stores itself can do an order periodically, once a month or whatever. Okay. Now the stores issue system, the mess secretary has to give a menu. In fact, if he gives a daily menu, it will be difficult for the stores issue to kind of issue the proper amount of items to the mess manager. So I am assuming a 2-day buffer. In other words, he should at least tell what the menu is going to be 2 days from now, in order to be able to order the right amount of perishable and perishable goods particularly, okay, to avoid wastage. So the menu of today plus 2 has to be given, and the items to be issued with 2 days buffer has to be told to the mess manager, and the mess manager has to in turn send a perishable ordering system. As you can see here, vegetables and perishable requisitions have to go, and this ordering system will order this. Separate order file is here, perishable order file, and vendor data for perishable items is there. Okay. So the point is, I have taken a large context diagram and I am now breaking it up into a number of parts, and each part is to some extent explainable and to some extent try to be self-contained and give an idea of what the situation is like. Suppose stores issue system finds out the low stock for whatever items have been asked in the menu, then that low stock has got to be told to mess manager so that he can order appropriately either here, or he can send an information here for the vendor for ordering non-perishable. Normally he said non-perishable will not really go low stock. It may no, the low stock may be only for something which is perishable. But anyhow, that's a matter of detail. The point as far as this particular talk is concerned is that you divide up into multiple parts. Okay. And now one itself, that is the one which I took, billing system, itself can be split into a number of parts. Okay. They calculate students' bills, reconcile payments, find number of meals to cook, calculate daily rate. See, there are number of things I mentioned in that, in billing. Now the billing itself, see the billing, billing system is numbered 1, okay, and the billing system itself is consists of a number of parts which I explained in words. So you put that down in greater detail in the expanded DFT for the billing system. So in other words, the point is that it is just like breaking up a large problem into smaller problems, and each smaller problem is further smaller problems which you can tackle. So it would turn out that each of these processes will be very simple programs to write, or maybe actually may turn out to be simple objects in an object oriented system you are looking at, okay, or it could be a simple function, whatever, okay, depending upon the method you are using for programming. But that is something for the system designer to decide. But the broken up thing, the intention is to make it somewhat simpler for the person down below who is going to use it to create programs. It is also kind of some use to the manager or person, the user, but this may not be of that great use to the user, because I am getting into greater details, but it may be, because at this stage you can kind of, any logical error which may be there in the system, you can point out saying that you have not done this, okay. So it is definitely understandable by both the user and by systems designer, okay. So each one of them has to be described in greater detail, and I think so the I will essentially tell that the point is that you have a part, billing part which is divided into 1.2, 1.3, 1.1, 1.2, 1.3, 1.4, and if you are further going to calculate students' bills into something lower, it will become 1.2.1 and things like that. You have some numbering system, okay. Like in a book you have got section numbers, subsection numbers and things like that. So with this I will conclude this talk, and we will look at leveling next time.